Here's our introduction to exponential and logarithmic graphs and equations. We'll start with exponential functions. So an exponential function has the form f of x equals m, or some number, to the x power. M is called your base. You can use whatever letter you want to there. The base has to be positive, so bigger than 0, and the base cannot be 1. Over here on the right-hand side is an example of an exponential graph. It seems to flatten out on the left-hand side. That is called a horizontal asymptote. You would write your horizontal asymptote as y equals whatever this number is here. This example has y equals 0. Okay, but most of our examples aren't going to be y equals 0. They're going to be transformed graphs. So how do you know where the asymptote is located? You have to remember transformations. So remember, y equals m to the x power is a basic exponential function. We can transform it by adding something to the exponent. Remember, that was your h value. If it's a positive number, you think it's going in the positive direction, but it's actually going in the negative direction to the left. And if h is a negative number, you think it's going in the negative direction, but remember, h is backwards from normal, so you're moving to the right. So I can add something to my exponent, or I can add something overall to the end of the equation. Positive numbers move the graph up, and negative numbers move the graph down. I also want to mention these negatives here. A negative in your exponent reflects across the y-axis. A negative in front of your exponent reflects across x. So it turns your graph upside down. Okay, so what do all these things mean? We're not going to worry about stretches and shrinks here, vertical stretches or vertical shrinks, horizontal stretches, horizontal shrinks. But what does all this have to do with a horizontal asymptote? The horizontal asymptote is located at y equals k. So whatever we add to the end of our equation is where our horizontal asymptote is. If there's nothing added, it's a 0. Let's do some examples. Give the base the horizontal asymptote and then graph the equation f of x equals 2x minus 1 all minus 3. Our base here is the number that we raised to the exponent, so that would be 2. The horizontal asymptote, remember, is y equals whatever is added to the end of the equation here. Okay, now we need to talk about transformations in order to graph this. A normal exponential graph goes through this coordinate point here, 1, 0. We need to use transformations in order to graph it. So that x minus 1 moves it in the positive direction, right 1, and this minus 3 moves it down 3. That means I need to take this coordinate point 0, 1 and move it right 1 and down 1, 2, 3. Okay, we want to plot our horizontal asymptote. Use a dotted line. And then your graph starts flat against the horizontal asymptote and then needs to curve up through the point 1, negative 2. So let me repeat how we did that. You plot your horizontal asymptote and then use transformations to move the coordinate point 1, 0, right 1, and down 3. All right, same idea here. Give the base horizontal asymptote and graph 5 minus 2 to the x plus 3 power. Generally, I like to write these negative 2 to the x plus 3 power and then plus 5 added to the end. That's how you would have always seen it from me, but textbooks and apps like to write it in the other order. They don't like to have negative numbers first. Okay, my base here is the number that is raised to the exponent. Bases have to be positive. So it's just the 2 that's raised to the exponent. That negative tells you to reflect over the x-axis. And the horizontal asymptote is whatever is added to the end, so y equals positive 5. Okay, now we're going to use transformations to graph this. So the negative in front of my 2 means I need to reflect over x, so it's going to be upside down. The x plus 3 means I need to move left 3, and the plus 5 means I need to move up 5. I'm going to start by plotting my horizontal asymptote at y equals 5. I'm going to take this coordinate point 0, 1 and reflect it over the x-axis, which means I need to change y values to negative. So I have the coordinate point 0, negative 1, and this coordinate point needs to move left 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5. Oh. Now start against your horizontal asymptote and then curve out through that coordinate point. This doesn't have to point straight down. Sorry, that should be more out. But you start flat against the horizontal asymptote and curve out through the new coordinate point. All right, last example for exponentials, and then we need to move on. Give the base and the horizontal asymptote. You may want to pause the video here and see if you could do this yourself before we move on. This is a different example from what's in your notes. Okay, the base is 4. The horizontal asymptote is y equals, oh, there's nothing added to the end here. That means I am adding 0. If I wanted to graph this by transformations, this plus 2 means I need to move left 2. So start by plotting your horizontal asymptote. 0, 1 is always my starting place, but I do need to move it left 2. And then you will start by being flat against your horizontal asymptote and curve up through that point that is supposed to be on here. I'm having so many issues. There you go. Okay, let's move on to logarithms. A logarithmic function has the form f of x equals log base m of x. Just like before, m is our base. It's going to be a positive number, so greater than 0, and it's not equal to 1. You read that log base m. The m is physically smaller than everything else in the equation. It's a subscript there. If you look at the graph over here on the right-hand side, it seems to point straight up and down on the left-hand side. That is your vertical asymptote. Remember, vertical asymptotes are written x equals a number. So how do we figure out where that number is? We can use transformations just like before. Recall that I can add anything as part of my equation, so that would be my h. If it's positive, you're moving backwards to the left. If it's negative, you're moving forwards to the right. Add something overall to the end of the equation. If it's positive, I move up. If it's negative, I move down. And these negative signs here tell me to reflect over y or to reflect over x. The vertical asymptote, you take whatever is written inside your parentheses and set it equal to 0. I do not plan to give you a reflection over y ever, so your vertical asymptote will be x equals negative h. So that means change the sign of your h value. Let's do 3 examples here. We're going to have to graph them. So give the base, the vertical asymptote, and graph. My first equation is f of x equals log base 2 of x minus 4 plus 1. So if you listened to me, you automatically realize the base is 2. The vertical asymptote, you take what's inside your parentheses and set it equal to 0. So my vertical asymptote is at x equals 4. When we start graphing these, just like before, you want to start by plotting your vertical asymptote. Ooh, I may not actually have space on this graph to show this. Okay, for these graphs, instead of using 0, 1, we're going to use the coordinate point 1, 0. And you also want to use the coordinate point 2, 1. This 2 is just whatever your base is. This is what Alex has you do. And just like before, now we're going to use transformations. So in my equation right here, this x minus 4 means that I need to go right 4. And this plus 1 means I need to move up 1. Let's graph this. I like to start by plotting my vertical asymptote. And then I'm going to take these two coordinate points, 1, 0, and 2, 1. I need to move each coordinate point right 4 and up 1. 1, 2, 3, 4, up 1. And take the second coordinate point, right 4, 1, 2, 3, 4, and up 1. Now you start by drawing against your vertical asymptote and curve up through those two coordinate points. Here is your graph. Let's do a second example. Give the base, vertical asymptote, and graph of f of x equals negative log base 3 of x plus 2. Let's talk about our base. It is the subscript after the g, so that would be a 3. The vertical asymptote, you take whatever is inside your parentheses and set it equal to 0. So my vertical asymptote is at x equals negative 2. Just like before, I want to graph my asymptote. And I'm going to take the coordinate points 1, 0, and this time 3, 1. That 3 is whatever your base is, and use transformations to plot. So we need to talk about what transformations we have here. The negative means I need to reflect over x. Remember that was change your y values to negative. And I have a plus 2, which means I need to move in the backwards direction, left 2. Nothing is added to the end, so I'm not going up or down. Okay, so first, let's change all these y values to negative. Negative 0 is still 0, and negative 1. So I will start with the coordinate point 1, 0, and 3, negative 1. I want to move both of these coordinate points left 2. 1, 2. And because it's been reflected over x, instead of me starting at the bottom and curving out through the coordinate points, so instead of going like this, like a normal log graph, I'm going to start at the top and against the asymptote and curve out through these 2 points. The points kind of do help you remember to flip it upside down because you need to curve out through them. Okay, last example, give the base, vertical asymptote, and graph for f of x equals log base 5 of x minus 3. Whenever you see an equation without parentheses, you assume that the parentheses are only on the x. If we're going to include the minus 3, then you would have to have parentheses. So if there are not parentheses, only the x is in parentheses. The minus 3 is a k value telling me to move my graph down 3, not an h value. My base here is 5. It's the little subscript that is right after the g. And my vertical asymptote takes take whatever is inside your parentheses and set it equal to 0. So my vertical asymptote is just 0, which makes sense. I didn't move my graph left or right any, so my vertical asymptote is staying at 0, which is where a normal untransformed log graph has an asymptote. All right, let's use transformations to plot this. So the coordinate points 1, 0 and 5, 1 just need to be moved down 3. So 1, 0 is going to be moved 1, 2, 3. And 5, 1 is going to be moved 1, 2, 3. And now I will start against the asymptote and curve out through those 2 points.